Okay. Hello, everyone. Hopefully, wow, that's kind of loud. I'm James. I'm with Corelight. What we're going to talk about today is integrating Corelight's open NDR into your existing ecosystem so you can automate alert response. By doing that, really, it's with better network evidence. And first, I want to start with saying is, as everyone is well aware, attacks evolve. The adversaries are going to get in, but how do you respond to that? And really what we're going to present today is we're going to talk about responding with a data first strategy, doing that with network evidence. Corelight integrates into your system so that you can transform cloud as well as network information into context-rich evidence. And it really helps you understand your network. And I think really what would go with is there's a ton of change in security. I mean, how many people have seen different devices, different technologies deployed in network? I mean, the only thing that's constant is change. And so really what we like to say is by giving you the network evidence, it's a durable advantage that's going to last as you go through your system. By all means, if you have any questions, ask your questions. As we go through the presentation, we'll also have time at the end of the presentation for questions, and we'll have a short demonstration. Let's see how this is actually going to work. The obligatory kind of agenda. What I think we're going to talk about, just a little bit about me, really a lot of time talking about evidence, Corelight, how it can help in your network. We recognize that very likely everyone in this room is working in security, already has IDS, already has a SIM, already has a firewall. What can we do to help make those things better so that you're better informed, so that you can really be faster when you respond to an incident? Now, I will say it has been way too long since I spoke in person. Katie, who's actually leading the course ahead of me, I haven't seen Katie in quite a while because it seems like everyone's been two-dimensional for too long. It's nice to be here and be talking. I thought this meme was really fitting, not only for today, since it's the first time, but also when we conduct investigations. Oftentimes there are lots of twists and turns during the investigation, things that were unpredictable. So, when you play telephone, maybe sometimes I change the phrase just to kind of see what's going to happen as it makes its way back around. What I want to tell you a little bit about myself, I've taken SANS courses. I took 401 and 501 Security Essentials as well as Enterprise Defender. Great courses, laid a fantastic foundation, met great people, over the years in taking the coursework and attending the webinars. But let's talk a little bit about, kind of me and where I came from. I've been with Corelight now for 4 years. I head up the sales engineers for the East and Federal teams. Before that, I had a brief stint at A10, and before that, I was with the MITRE Corporation for 11 years. If you're not familiar with MITRE, we work with the federal government, supported lots of organizations and agencies, both at home and abroad during that time. I hope you enjoy the presentation. We should have a lot of interesting talking points as we go through. How many people have taken like the Security 301, 403, the ICS courses? Are any of those kind of coming through and ringing true? Because one, as I was looking through the coursework, what we have, a lot of those are covering, I think, what 450 and 595 talk about intrusion detection, network security monitoring, and machine learning. Those are all things that we're going to talk about today. And hopefully what you'll recognize as we finish the presentation, the skills that you're learning at SANS, what you're learning, applying in the labs, can be directly applicable using Corelight solutions. So I will tell you what Corelight is and what it isn't. I will tell you it is not an adult beverage. I possibly have been signed in once or twice when I go somewhere thinking that I'm with Coors Light. I'm like, no, that's a beer, but thank you very much for the brand recognition moving through. So Corelight we're an open NDR platform. And what do we mean? That's part of what Gartner calls the SOC visibility triad, where you have your endpoint. Everyone's familiar with the endpoint detect. You have your SIM, whether it's QRadar, conversation about QRadar, Elastic, Splunk, Humio, Devo, but the network side. We're really going to talk about the network evidence and what we can do. Now, Corelight's technology has been built on open source continuously for the past 20 years. There is continuous detection engineering that takes place, and we'll talk a little bit about that. But there's also Corelight Labs. So we're actually producing detections, ways to come up with novel approaches on your network. Unfortunately, as you all are well aware, There are very talented folks trying to figure out how to defeat preventative technology. So in addition to preventative, you need something that's really helping you with investigative. We'll talk about that. Corelight was created by the founders and maintainers of Zeek. It's been deployed, hundreds of customers, lots of large organizations. One organization actually needed to monitor 400 gigabits of network traffic, and Corelight was able to meet the challenge they had. But we're a private company, kind of interesting. CrowdStrike actually has invested in Corelight in our most recent round of funding. They have a Falcon Fund venture capital, and why we mention that? Because they recognize that Corelight is a leader in the network detect and response category. We are very complementary to their EDR product and their SIM product, their XDR, that they've released. So we're going to talk about what Corelight can do. It all starts with network evidence. Adversaries can't evade the network. Why? People may remember the old Rainbow series of security books. If not, that's good. You didn't miss anything. We're reading about those. The only secure computer was one that wasn't connected anywhere. When you have your endpoints, unfortunately, they can be evaded by the advanced adversary. Every attack that you have has to cross the network. So what we find is that successful defenders come through and they're looking and using the network evidence to come back over time, because unfortunately people get by the detections. The network doesn't lie. What do I mean when I say it doesn't lie? Unfortunately, when we have threat intelligence, when we have detections that were built, there are false positives as well as false negatives that are going to happen. It's a fact of life. Whether you're using a network detect and response solution or an endpoint, there has to be tuning that's going to take place, but they can't lie because they're going to leave a trail. What you don't want is something to become an unreliable narrator. So sometimes if you put too much trust in your endpoint, the adversary, if they're already in your network, they're going to be able to manipulate the message that you see, or they're going to fundamentally attempt to subvert that. They can try and obfuscate their traffic. They can try and look legitimate, but going to leave a trail on the network. That's really the point we make with the network. That's what drives evidence. The evidence that you have is really going to lead to the decision advantage. The more you know about your network, the more you can discover. Everyone always likes to talk about, how many people have ever heard the adversary described as Mr. Magoo, kind of bumbling and not being very efficient. Whenever we talk about an adversary, we talk about someone that's like a cat burglar. They're very dexterous, they're very agile. I would argue that the first time an adversary gets in your network, they're like Mr. Magoo. They don't know where they're going. They don't know what the layout is of your architecture. That's an opportunity where you can catch them, and you can look east-west, and we'll talk about some of the things that you can look for with this evidence. And last, this is what helps you be disruptive. As I started off the presentation, the adversary is going to get in. I mean, hands down, they will. The question is, can you stop them before they achieve their objective? You don't know what their objective is. Is it getting information? Is it ransomware? What you want to do is, before they can actually successfully complete that mission, you want to be able to disrupt them. And the network evidence gives you the power to do that. So let's look at two specific examples. I'm assuming everyone has heard for Log4j, Log4Shell, just putting it out there. With this, the severity was massive. It affected teams globally. Think about everything that used the vulnerable Java logging framework. There were challenges left and right. That wasn't the only problem. When you talk about SolarWinds, granted, it was a year and a half ago, 2 years ago, they said they had 18,000 workstations that downloaded a compromised application. Between those two, I like to bin them in two categories of kind of near real-time searching for something in the Log4j for something that's vulnerable, and, oh, I need to look back 6-9 months. And they're very different use cases, but you can use network evidence to assist in both of those. As we go through, when customers were looking through Corelight data in each of these, within hours, when there was an indicator, they were able to look and determine if they were affected, in either one of these instances. Splunk has the Surge team. It's their security researchers. When they released their first post, Splunk said, look in the Zeek logs. Zeek is a component that's deployed within Corelight. They said, this is how you can determine if someone is using the primary attack vector in Log4Shell. Corelight Labs then expanded upon that and said, people are changing their attack vectors. These are the other things that you need to look for. It's not just in the HTTP traffic. It can be in LDAP. It can be in DNS. You need to be sure that you're looking across all of these various attack vectors on your network to understand if someone is trying to exploit the Log4 shell moving through. There were detections that were deployed freely in the open source community, but let me go ahead and change something here on my screen. What do we have? Mandiant, actually, that's another interesting point. Sorry, looking at my notes. So Mandiant, who was really the canary in the coal mine for SolarWinds, they actually were the first to really state the importance of network security monitoring and evidence. Because when they discovered that there was a compromise, they used the tool open source Zeek in order to conduct the investigation, but it was also some of the content that Corelight had released, in looking at encrypted traffic, trying to see what is the adversary doing to try and obfuscate themselves on the network. All of these, these are just two stories, but there are a lot of other stories where the evidence on your network really helps to drive response. It also helps to work with your preventative technology to ensure that it is preventing and it's stopping what you think it's stopping at your border. Is this making sense? Everybody kind of agrees, disagrees? Am I crazy standing up here? See a lot of eating. Hopefully the food is good. So really want to talk about evidence is value. It's not just a strategy. So evidence is the heart of security. When you want to investigate something, the first thing that you want to understand is the environment. You want to understand via evidence before you make a decision. After you have that evidence, then you want to look to your analytics to tell you, was this something that was good or was this bad? How many times have you gone through or looked at something that at the point in time when you looked at it, you weren't sure if it was benign or not? It was only the next day, the next week, the next month that you looked back and you were able to look and say, that thing that I saw actually was indicative of bad adversarial behavior, but I didn't know it in my network. What you need to do is we need to collect the evidence today so it puts us in a better position for tomorrow. Because unfortunately, if you don't collect the information, you can't go back. There are really no do-overs, no take-backs, as my children like to say. They want to time out because they want to do-over working through this. For critical incidents, you really need the evidence because it's going to drive the speed of your response. So that's why we think this helps you try and catch advanced adversaries, in the act. It's really what you're looking for. Now, I've talked a lot about what NDR is abstractly. How does Corelight fit in this? So what I would say is Corelight deploys wherever you need it. What you'll see are several options with the, everyone's familiar with cloud and physical and even virtual with VM. Software side is something slightly different. So in this instance, it's really a microserver to deploy in those odd instances. Do you have something that's an IoT device? Do you have something that's just Linux-based platform that's outside of the norm in your environment? Corelight deploys across each one of, really any scenario you can imagine. With this, we're a passive device. So we're dependent on being fed the data from a packet broker, from a network tap, from cloud traffic mirrors. But as we mentioned at the start of this, you already have an ecosystem. You have threat intel feeds. You're receiving an intel feed. You have intrusion detection signatures. You're using IPAM, IP address management in your environment. You already do all that. So how is Corelight going to help? So what if you're using IP address management, whether it's Rumble, for example, Infoblox or BlueCat? Because you have devices that IP addresses change, what if you log those changes as they happen in your network? So you can see over time if you have nefarious behavior, but the IP address is changing, but it's really the same device. We want to give you that level of visibility. What if vulnerability management? So we have an integration with Tenable Security Center and also with Falcon Spotlight. So you have a system that has a known vulnerability. You can't patch it yet because it's going to affect production, but you want to know if someone attempts an exploit against that system. So Corelight has a way we can, through working with the API, we can take that information in, and if we see that, we're going to put that to the top of the queue. That's the most important thing that you should be looking at to triage. Again, we want to integrate in with your existing vulnerability system with your IP address management. What about through the cloud? What about containers? The life of a container, and we'll talk about that in a few slides, the life of an EC2 instance is really measured in seconds and days. How are you going to know what actually happened when you need to look back last week, last month, or even possibly last year? We'll talk about how we can do that, how we integrate and enrich all the logs. Enriching those logs. Oh, that's not good. Oh, sorry. My connection disconnected from my VPN. Hold on. There it is. Okay. Later on, I'll have to reconnect for the quick demonstration. But we mentioned we send alerts and logs. So those logs we send are going to be enriched. They're going to be context rich. So you understand what it is. It's not going to be minimal and say that there was an error. It's going to tell you where this device is located. It's going to tell you if this is an attempted exploit of a known vulnerable system. Also, those alerts, signature-based alerts with context. So now if you have an alert coming through, and we'll give an example of this later on, you're going to have context around that. So you can either automate the response or you have the information to determine if it's legitimate or is it a false negative. But that's not all. So what about files? Does anybody do any work with pipelining for static or dynamic file analysis or any of your organizations? Look at that. That's something that some folks are interested in using Cuckoo, for example, or putting it off for, can't remember the other, Wildfire with Palo Alto. But sometimes PCAP, I want to capture with PCAP. Why do you need the PCAP? Do you need everything or do you need to filter it? Corelight has taken a unique approach for PCAP that we call Smart PCAP. So in the Smart PCAP, it's really complementary to those enriched logs. So you're only going to capture interesting packets. And we'll talk about how you can define that and what actually means what is interesting so that you can keep it for a longer period of time. Instead of keeping it for 2 weeks, what if you could have it for 60 days, 90 days, 180 days without needing an entire rack of spinning disk? And, I'd be remiss if I didn't mention, software as a service. So Corelight has an option we call Investigator, and I'll give a brief demo of Investigator, how you can investigate, hunt, triage alerts using either machine learning, signature-based queries, or behavioral-based information. We'll give quick examples of each of those. Who remembers when this, iron just meant a single service or a handful of virtual sites or even maybe tens of VMs? Now this can mean hundreds of containers are running in your environment that you have to manage. You need to be sure that you're on the lookout for any exploitation. But if you have each of these, namespaces could be running, in this instance, 10, so this could be 50 Kubernetes namespaces. How do you know what's running today or yesterday? How are you going to investigate that? It becomes a significant challenge to track your nodes or your pods. What about AWS? Everyone, no longer does everything sit neatly in a data center and you can point to the rack and say, this is my rack of equipment, or this is my floor of equipment. It usually spans multiple data centers, spans, multiple deployment models. So we looked at this and said, I mentioned earlier, there was a ZDNet article I was reading that said, for containers, the average lifespan of a container, 54% of containers only last 5 minutes. 20% of containers only last 10 seconds. So all of a sudden, IP address, FQDN, those become very difficult to track over long periods of time when you have high volumes of instances turning over, changing. 50% of those containers in, I think, 1 to 2 weeks are completely reworked. So how are you going to look back in time to see if you have a more systemic problem, with your network? That's really, again, where the evidence is going to help. What about in AWS? There was a group, Spot Interruptions, said it's 4 to 10 days is what the lifespan is of an EC2 instance. So we've got, 4 days, 10 days on the long side, down to, numbers of seconds on the other. It really makes it a challenge to come through. And, I kind of jokingly said, how would you find Bob, Stuart, or Doug, in this? Because they're there, but how are you going to find them? It's kind of a take on the old Where's Waldo. It's becoming more and more challenging, and they're putting an increased burden on our security teams in order to investigate, to prevent, to be efficient. That's why we talk about the evidence that's going to help. Now, I want to pull this thread in AWS. We're going to talk about VPC flow logs briefly and how you can use that to monitor what comes and goes out of your VPC. Has anybody taken any of the cloud courses of SANS this time or a prior event? Anybody with cloud? Okay. So this is what, kind of VPC flow logs look like. And there is useful information here. Now, you can get additional information, that can be added, but it has to be configured whenever you want to use this. Is this enough information? I mean, I don't want to be pedantic, but in 1999, this is like what, NetFlow looked like with version 5 when it first came out. It's great at telling you 2 endpoints, they communicated, how long did they communicate? There is additional specific information relevant to AWS with your ENI ID, for example, and you can add additional information to this. But again, you have to configure that. Well, let's look at Corelight data and see. The first thing we're going to talk about is this is what we call our connections log. So sorry, it may be a little small. This is a log that summarizes a connection, very much like a VPC flow log, but it has additional data. So you see at the top, we're saying what type it is. This is connection because it summarizes. We have other types of logs also. I'll give 1 or 2 examples in a minute. The second item down there is a UID. It stands for unique identifier. If anybody's familiar in databases, that's like equivalent of like a primary key or really a foreign key. It lets you pivot into other related logs. So that's going to allow you, if you see a summary connection that says this is something of interest, you can use that value and you can pivot into related data to get additional context. And we'll have an example talking about that. Service and prototype or protocol, it's easy. I personally like this one, the history. So does anybody know what SHEDIF, could mean? It's when we go through, capitalization tells you orientation, who starts this. So the originator. So what this is showing you is, this is a summarization of the TCP control flags. So I've got my SYN, my SYNAC, my ACK. I have data sent, my data is acknowledged, more data is sent from the responder, and then it ends with a FIN. So I could look at that in my SIM, and I can understand pretty quickly that that was a healthy connection. It was initiated, data was transferred, and it was gracefully closed. So I could troubleshoot that if I had a problem on my network or wasn't graceful. I could also look for the adversary. Earlier in the conversation, when I said sometimes the first time, often when an adversary gets into a network, they kind of bumble around like Mr. Magoo. If they send a request looking for service, they're going to send that SYN packet. And if there is no service, it's going to come back with a reset. So if you look for an S and an R, a SYN and a reset, you either have a service that's down, so you have a problem in your network, or you have someone doing reconnaissance in your network. Something easy to look for. But what if we took this information, specific information? So in this case, we're adding, the organization, the region, the VPC, and the instance ID. So we've appended that and we've enriched that. So now, in addition to knowing about the connection, I'm telling you the AWS information so you can track down details of that EC2 instance. But what if we could do the same thing with Kubernetes? So in this instance, what you'll see is we've got both the originating pod information and the responding pod information. So we're appending all of that so that you have the opportunity to use your existing tools, your existing configuration management to find out what you have in your network. So what does it look like? Well, if we use guard duty, really common AWS tool, I see that I have, a malicious caller. Let's drill into that. I'm going to get good information. The overview, the instance details, the network interface. That's good and that's a start. But what if I had better information? Because you can enrich Corelight through the API to add that information, now you can pivot from guard duty into your Corelight data and say, okay, I know this is the event. What actually happened? Well, I can see it's HTTP. I can use that unique identifier value now to pivot into the HTTP log. And I can get information about what's the user agent, what was the status code, the message. In this case, files were exchanged. So I have a file unique identifier. So now I'm using a native tool in AWS. I'm expanding it, building out my ecosystem, with this data with Corelight. Now, this is not particularly exciting to just see that someone used curl, but you can see how it can be built. What if you could put security group information from AWS in that? So now you can see this security group allowed this connection. These are the protocols that went through that connection. Is someone actually trying to usurp just using a benign port 80, but they're actually transiting SSH traffic across that? These are the types of things that you can do when you have better network evidence coming through. So when we talk about Corelight, we've got the 3 pillars. We've talked a lot about evidence so far because we have protocol logs to show what's happening on your network, how you can pivot with a unique identifier, and we talked about custom data enrichment. So it's a lot more useful coming through, and we can do a lot of protocols. I mean, there are additional ones. You can write custom protocols. Pretty cool. What we haven't talked a lot about are the signatures and the insights. So in this case, we're going to talk about what we can do with IDS signatures, a little bit about behavioral analysis and machine learning. I'll demonstrate when we get to our investigator platform, because we do this through some of the content that we built for command and control. So we can give you encrypted traffic content. Do I have a newly minted certificate being used for TLS traffic on my network? Do I have one about ready to expire? If I have an SSH session, because maybe it's allowed, but do I allow people to transfer files across that SSH session? Independently, none of those is indicative of nefarious behavior, but it could be. And so again, we're giving you the evidence so that you can search if you have something to say, what is that? I want to know more about what's happening on my network. Before I show that, I thought this was a pretty interesting quote. Before we talk about orchestration, it's 20 years old. I remember when this came out, intrusion detection is dead, long live intrusion prevention. Well, I don't really find a lot of organizations that have the confidence to deploy IPS in a blocking mode. Because usually what happens is you've done it once, you blocked the wrong thing, and all of a sudden your phone is on fire, from all the rings. So now you're no longer doing it in active blocking mode. You still want to know, but you're not going to actively block. But what was the goal of all of this? The goal of the IPS was to optimize workflow, integrate detection, response, investigation all in one. That's what was promised by SIMs when they first came out. Again, Splunk, Elastic, Devo, that's the goal. They're working to get there, still not there. Do we have any Monty Python fans in the crowd? Because, really, as I would say, that's what everyone is working towards. Everyone wants to get to the Holy Grail. And we're not alone in that. But the difference I will tell you is Corelight has evidence, and that evidence helps you get along that path. So how do we do that? So what we have, this is actually showing an interface looking at the Corelight data in Splunk. The first thing we'll talk about is this is a combination. One of the things Corelight does is we combine intrusion detection information with that connection information to summarize the content. So here we can talk about the alert category metadata, the severity and the signature, the flow ID if you're using Suricata, and another value that's unique to Corelight called community ID. This is really unique because what this allows, we actually release this in the open source, to check our data with other data sources. So if you have the 5 primitives of IP address, source and destination, the port, source and destination, and the protocol, you can generate this community ID value, and then you can say, my firewall flow, is it agreeing with Corelight? Or this endpoint that generated this traffic, does it agree with what I'm seeing on my network? We think it's great and really assisting in that orchestration, as you go through with your SIM tool. But what you're really interested in is looking and getting logic. So we take that unique identifier and we do an investigation. The investigation, has anybody worked with XOR or SOAR, formerly known as Phantom or Swim Lane? It's a bunch of if-then statements, that you come through. What if you can ask those if-then statements, come through with your investigation and say, I want to use this value to come through and tell me what I see here during my investigation. So in this case, because there was a file, I can take that hash. I can then go to an external data store. I can go to VirusTotal. I could go to an internal data store where I can see what is this? Is this malicious? Is it nefarious? Have I seen this before in my network? Now, this is a grossly simplified example, but you could do the same thing with a SQL injection attack. When a SQL injection attack happens, You want to look in HTTP and look for the status code. If I see a 200, it's going to be a bad day, because that means someone initiated a SQL injection attack and my server responded okay. If I see a 400, I need to confirm, but very likely that connection failed, or that attempted exploit failed, so I can push that down the queue. I can go do other things that are higher priority in my environment. This is really what we're looking for, or what we want to provide is, it's the linkage. Taking that identifier, finding this particular field, in this case, it's the files log, using the values that are traced there and going to an external source. We actually make this information available on our Corelight GitHub site. We have a couple of playbooks that we published, and we're really looking for feedback. It's one of those items, if you have feedback, something you'd like to change, something you'd like to update, we want to put it out there. We make it freely available to you to go through, because we think this is the power of evidence. This is what's really going to help us be more effective as we do our jobs. The last piece that we haven't talked about really is packet capture. So what Corelight has done, as I mentioned earlier, it's selective. I'm going to talk about how we can do I'm going to demonstrate one-click retrieval coming through and my kind of initial thoughts for what I like. But fundamentally, it allows you to augment the Corelight logs if you don't have the data that you want in the logs. And we find that probably 85, 90% of the time, all the information you need is already in the logs. These are some of the levers that I like to start with. If I'm monitoring and I'm logging traffic on my network, I want to know if I have an unknown TCP or an unknown UDP connection. When you go through, and I showed the log earlier, we said this is HTTP traffic. I know that, I'm expecting that. If I see traffic on a port and I don't know what it is, I can't see that it's NTLM, Kerberos, I want to know what it is. I want to capture that so I can conduct an analysis. If I have something that is not adhering to an RFC, I want to know about that. I should only have TLS, 1110 on my network. Why do I have something else that looks like TLS, but it's not? I also really a big fan of capture everything that's unencrypted, but a slice of it. Don't give me all of it. Give me a sliver, because then I can see everything I need from the header. And what do I mean by this? If you take a network today, how much of the traffic is encrypted? 50%, 80%? It's going to vary, but it's a significant amount of traffic is encrypted. We have an encrypted traffic collection to give you information about that. So I talked about, newly minted certs. What are they doing on SSH? Stepping stones. Is someone using SSH tunneling to try and obfuscate where they started their connection from? There's some portion of that are files. We can extract the files. That really leaves 10 to 30% of the traffic left on your network is something that may be of interest. But how do you know? You don't need all of that, because we have very detailed protocol logs. What if we had a policy that said, capture everything that Corelight doesn't parse and the first 2,000 bytes of your traffic? By doing this, now you have something, if it's unknown, we want to know about it on our network so we can figure out, is it a mistake? Is it something we can do, as a vendor to do better? Or maybe it's a custom protocol in your OT environment that you can develop using Spicy. Give me the first 2,000 bytes. If an adversary is going to do something on your network, are they going to initiate a connection and then just kind of send no op and null for 10 minutes or for 5,000 bytes? I don't think so. If they're going to try and exploit a vulnerability, they're going to do it quick as you go through. Grab the first 2,000 bytes, you'll see it. So in this example, if somebody has a 7 gig of daily usage, and we're say 10% they're going to capture, with 500 terabytes, you have greater than 60 days of retention. And I think the important piece of this is Corelight, we're working with you if you have your own hardware. So you don't need to buy racks and racks of spinning disk. 500 terabytes is pretty reasonable to have in a small form factor environment. What does a rule look like? In this case, we're defining the rule and saying, if I see something weird, remember, it doesn't follow the RFC, notice is really in our vernacular for an alert, a custom alert that either has been built by the community or by Corelight, unknown, grab the first 1,000 bytes, I call it time machine, but apply it only to this IP segment. So each one of these rules is applied to a different segment. In this case, this is the catch-all of the any rule, because I want to apply If there's something else coming through my connection, I want to capture everything. What does that look like? So inside of that rule that we have here, talking about the weird and the notices for the 192.168.1, I define the protocol, the IP address, if I want to be more specific, and the action. Then I can define the levers that I have. In this case, I choose a Zeek event, and then it drops down to weird. 0 means I want everything. Give me everything that you've got. But in this case, as another, just an example to show, I want all traffic. We give you the chance to capture encrypted also. I don't think there's a lot of value in that personally with the elliptic curve key exchange, because your keys are ephemeral. It's pretty hard to grab the keys to, see in your TLS session. But if you want it, you have it, and give me 2,000 bytes. So now I've got all that header information, so I can see what's going on in my network. Does anybody have any questions so far before I sign in? I may do a quick kind of demonstration with Corelight on our smart PCAP with Investigator. It's a little slow to respond. Give me a second. Okay. So what I'm going to show you here, hold on, is this? Sorry, I can't. In Investigator, and this is trying to make it for everyone to see what we're doing. We're summarizing entities that have alerts. So in this case, an entity can be an IP address, or it can be a fully qualified domain name. You have a question? So the question is, can we do offline forensics with the packet, with the tool, with the Investigator tool? So you can actually replay traffic through a Corelight sensor, and then it'll generate the logs that we would have, with a context for analysis. And I'll talk about why that's valuable if I can get my other screen up, because I show you can pull a PCAP for Microsoft's SMB protocol, or you can look and see we have an SMB log that's going to give you the information to show you inter-process communication and the name of that to try and simplify it some. But as we go through, we define your entity that you have, and we're going to tell you kind of the alert categories. In this case, you'll see we've got some from machine learning, some from Suricata. There are also some that are generated from notices. Notices are behavioral based. So the way that Corelight works, we gave you the option to really look at traffic and make a decision based on multiple kind of instances, again, in that if-then statement. If I see this, then I see that, and if I see this, to go through. And we'll give an example of that. If I can get this to, let me pull this, give me 1 second. I don't know why I cannot do anything with this screen now. Give me 1 second. No. Investigators, is it? Aha, there we go. That's what I was looking for. So I pulled this up earlier. Let me sign in with my VPN credentials because it signed me out. And what you'll see as we go through this, I already have some of the tabs brought up because I didn't want to be hunting through to find everything. In this instance, this is a Eternal Safety, the Eternal Blue kind of family of exploits that went through. This is a community developed detection that was released. And so in this instance, it's something that we brought it to the attention that we saw the alert. These are the entities. So these 2 IP addresses, and we saw it this many times. We try and summarize it so you don't have a screen full of alerts coming through. But then we give you the option to go through, and you'll see, remember we talked about the unique identifier and the value the unique identifier has. You can go through and investigate the logs where we use this particular unique identifier. So what does that look like? As we go through, in this instance, I'm looking in what's called a notice log. Remember, that's our custom alert. And I'm looking for internal safety because I'm drilling into something I already found. Now, in this case, I'm looking for something from my sensor because I wanted to be able to demonstrate pulling the smart PCAP because it's my workstation can find that. But here we're defining the information. We're telling you what we found. In this case, it's an SMB version 1 violation, possible Turner Blue or buffer exploit, the IP address that did it and what they did. If this is not enough information, if you want additional information, we use that same unique identifier value to go through and say, now I want to see that connection, that summary connection of that particular session. As I go through and I look at that, I'm going to have access to the data to see. Sorry, that's really small on that side. You'll see community ID as one of those values that we talked about before. So here I can pivot to other data sets. I can join things with my EDR, but also in this, what's really of interest is going through down, you'll see smart PCAP rule, smart PCAP trigger, and then the URL. So now, and I could do this in Splunk, Elastic, Devo, Humio, any of the SIMs that you have. I've told you the rule that we have. I've told you which one in particular, which number, which one, and then I have the URL. So then if I go through and I click the URL, need to copy, go to that. Oh, it didn't, I guess I'm not in my VPN. Well, I guess that's what I get for not pulling it down already. And to come through, that's where we give you the opportunity in a single pane of glass to come through so that you have that. But the question the gentleman asked earlier about what do the logs look like? In this field, you could pull the PCAP down and you can look, but if you see, we have our SMB mapping feed log. So here you see, these are the notices. Suricata also tripped on this and we have our summary. In the SMB mapping at the top, what this is going to give us is information about that connection. Oh, clicked on the wrong. There it is. And really what I want to just show in this to finish on is where you can see the information there in the path. So here what we're showing is the inter-process communication coming through. We're showing you the service. We're giving you a lot of the information, telling you the type that it's a pipe. What do you need? What else do you need for the PCAP? We want to make it available to you so that you can use this to get the evidence that you need, so that maybe you need PCAP, but we're going to set it up so that you're not dependent upon that, going through. That's what we wanted to show. Sorry, I couldn't pull the PCAP through with that. I couldn't get my connection to my VPN going. Let me quickly go back to my presentation. Where did my presentation go? Can you tell I haven't done this in a while? That's what I want. It's my last slide. Can't. Sorry, this is. Minimize that. And if you also can't tell, I'm kind of a fan of the space telescope data that they've been recently putting out there. Is this the one? Yes, okay. There we go with our luncheon. So really kind of just to summarize, we have alerts and detection are necessary, but you need more, in order to have that with evidence. We give you durable advantage by having that. We have a platform that transforms network and cloud into evidence that really gives you actionable insights. We can help integrate into your ecosystem, integrate quickly, take information from Infoblox, from Blue Cat, from Tenable, from CrowdStrike, so that we're really merging, so that you don't have a silo of excellence in your security side. You're actually merging using all of the tools that you have when you respond to an event or an incident. And that's really it. Kind of thought we'd finish with some of the guys like to call it our glowworm slide. It's kind of colorful. I don't know if anybody has any questions coming through. Yes. I'm sorry. Absolutely. So what you can do, the tools that power Corelight, Zeek as an open source capability, you'll learn about Zeek in several of the courses, I think in the 301, the 403 that you'll take. You'll learn about Snort in a lot of your courses. I think maybe Suricata also. Suricata is also available. Corelight has a thing that we call Corelight at home. So if you're interested in Corelight, we give you the chance to run it on a Raspberry Pi. So you can run it at home, get an idea for what the data looks like, the integrated solution of having Suricata as well as Zeek with Smart PCAP all in one. Excellent. Thank you, everyone. Have a great afternoon. Enjoy.